guys, so this is our continuation of our mole notes. We started talking about the mole yesterday. We learned that the mole represents a number, so just like a pair represents 2, just like a dozen represents 12, a gross is 144. We know that a mole means how many, children?
6.02 times 10 to the 24.
23rd.
Third.
Okay, so 1 mole is equal to 6.02 times 10 to the 23rd particles. And we said that particles is a really broad general term. So particles could represent atoms, particles could represent molecules, particles could represent formula units. And those are the 3 most common ones that we'll use. So we did a few examples yesterday in class, and I just want to go over a few more before we move on. So I want to calculate the number of atoms in 0.120 moles of sodium. So first I want you to also look at this and be reflective and evaluate. Would it make sense that I use the word atoms with the element sodium? Would that make sense? Yes. Should be saying yes, because elements are made of atoms, so I can have atoms of sodium, so that's good. So atoms in 0.120 moles. So I have 0.120 moles of sodium. My goal is to change it into atoms. So I really want atoms of sodium. My goal is to cancel out this unit of a mole. So I can divide by mole, because now what happens to those two? What happens, class? They cancel out. They cancel out. But now I need to figure out what numbers are going to go here. Well, I know that Avogadro's number is that for every 1 mole, there's 6.02 times 10 to the 23rd atoms. So I would take 0.120 times 6.02 to the 23rd. I'd multiply those, and you should get 7.22 times 10 to the 22nd. And that's atoms of sodium. Easy enough? Yeah? Good? Easy? Okay, let's move on. And I'm just following along, guys, with your slides. So we're on now slide number 9. So this says, how many moles of potassium are in 1.25 times 10 to the 21st atoms of potassium? So I gave you 1.25 times 10 to the 21st atoms of potassium, and I want you to convert that to moles of potassium. So you're given atoms, I want moles. So I'm going to take the number that I gave you, set up my work. So here's atoms. My goal is to get to moles. I know because Avogadro's number relates particles to moles. So my goal is to get rid of these atoms. I can do that if atoms is on the bottom of that ratio over there because they'll cancel. So I know how many atoms are in 1 mole. How many, children?
6 point times 10 to the 23rd.
Very good. 6.02 times 10 to the 23rd. So in this case, it would be 1.25 times 10 to the 21st times 1. And then I'm going to divide that by Avogadro's number. So if I take this number and divide it by Avogadro's number, you should get 0.00208 moles of potassium. Okay, so we can switch these. We can go from atoms to moles. We could go from moles to atoms. We could go from molecules to moles, from moles to molecules. So they're just kind of switched around. So in one I'm multiplying, in the other one I'm dividing. So the next slide that I had for you guys was doing some practice. And this is slide number 8. This is slide number 9. Okay, well apparently this is slide number 8. So on this slide, I have 4 different problems set up for you. We just did the first problem together. So we did how many moles of potassium are in 1.25 times 10 to the 21st atoms of potassium. For practice, I would like you to do these 3 for me. So I'd like you to... There's also one that's a challenge problem where it says you're doing the exact same thing, but I want you to identify what the representative particle would be. So for example, if I gave you this first one, let's say that these are particles and I want you to convert them to moles. So I gave you 3.75 times 10 to the 24th particles of CO2. Would CO2 be an atom, a molecule, or a formula unit? Would CO2 be an atom, a molecule, or a formula unit? What do we say, class?
Molecule.
It would be a molecule. Tell me why.
Because it's a covalent bond.
Because
Covalent bond and 2 nonmetals. Very good. So that's carbon dioxide. That tells me that it would be a molecule, or molecular compound.
It's a molecule.
So this would be 3.75 times 10 to the 24th molecules of CO2, and I want you to convert that to a mole. This next one, I have 3.58 times 10 to the 23rd, and this is zinc 1 chloride. Is this a formula unit, a molecule, or an atom? What is it, Matt?
Formula.
It's a formula unit. Why is it a formula?
Ionic bond.
Because Matt Tracy said so.
Because it's an ionic bond. I know that because there's a metal present and there's a non-metal present. So that would be ionic, which would tell me that it's a formula unit.
It would be a formula.
So we have a molecule, we have a formula unit. So that's what it means
Molecule plus formula unit.
by identifying the representative particle for each. So tell me, is it a formula unit, a molecule, or an atom? So these are 2 more example problems that you can do. But what I'm asking for you to do are these 3 and bring them to class for sure. So I have this
Bring
one,
them
this
to
one,
class.
this one, and I want these done when you come into class tomorrow.
She wants these done.
We'll do these together. Let's
Do
keep
this
going.
together.
Next thing is something called molar mass. Molar mass is the mass in grams of 1 mole of any substance. Molar mass, I have 1 mole, and it's just going to be also describing mass in grams of something.
It's not you. It's not you.
Okay, so molar mass, again, is the mass in grams of 1 mole of any pure substance. So, guys, molar mass is really, truly one of the simplest things ever. The molar mass of any element. So if I take any element or look up any element on the periodic table, if I look up its mass, that is its molar mass.
What
So
if?
let's look over here to the periodic table. For example, I have iron, Fe. The mass of iron says 55.847. I know those are grams. So let's say I have 1 mole of iron. 1 mole of iron is equal to 55.847 grams. So a mole is just how many of these we have on the periodic table. So I see iron has a mass of 55.847. This must be a mole of iron. Aluminum has a mass of 26.98. That's grams. So in 1 mole, there must be 26.98 grams of aluminum in 1 mole. Boron has a mass of 10.81 grams. So that must mean in 1 mole, there's 10.81 grams.
10.81 grams.
Okay, so on here I just wrote, if we have iron, in 1 mole, there's 55.845 grams. So that's what that means. Molar mass has a specific unit, and that unit is gram per mole. So if I look at my periodic table, I know, like we just said, that iron is 55.845 grams in 1 mole. So that's why we can say per 1 mole, okay, per a mole. Okay, let's look at some problems with these. So convert 3 moles of copper to grams of copper. So I have 3 moles of copper, and I want to convert that to grams of copper. I can use molar mass to do this. So 3 moles of copper, my goal is to convert it to a gram. I need to get rid of moles. Well, I know that molar mass uses the same units as grams per mole. So if I look up the mass on the periodic table of copper, Luke, what's the mass of copper? See you.
63.546.
63.546 grams
63.546 grams.
in 1 mole. So I'm going to take 3 moles, multiply it by the mass of copper. When I do that, what would I get there?
What would we get? We would get that number.
You would get 191 grams of copper.
191 grams.
So
of
I
copper.
can use, yeah, roughly. So I can use my molar mass to figure out how many grams of copper I would have in a sample. Let's do another one of these. Let's say I give you 0.045 moles of chromium. Moles of chromium. And I want you to convert that to grams of chromium. So I gave you moles of chromium,
Convert
I
it.
want grams of chromium. So let's first write out what I gave you. So it's 0.045 moles of chromium. I want
0.045.
grams of chromium. What unit will go on the bottom of that ratio there? Moles of chromium. Why? Awesome. Cancels out. Shayla's killing
Good
it
job,
over here.
Shayla.
Killing it. Okay, so we have moles of chromium canceling out. My goal is to get grams of chromium, so I can do that. But now I need to figure out numbers here. So I know that on the periodic table, the mass of an element is equal to however much it is in a mole. So grams of chromium, my mass of chromium on the periodic table, Luke, is what? Chromium. 54 point, say again.
51.
Oh, 51.
51.996.
And that's in 1 mole of chromium. So now, what would I do with these two numbers?
You would convert them.
I'm going to multiply them. So I'm going to say that that's 2.34 grams of chromium.
Chromium.
Let's do one more. I want to know if I give you 25.5 grams of silver,
grams of silver.
I want you to convert that to moles of silver.
Convert it to moles of silver.
So I have 25.5 grams of silver. I want to convert it to moles of silver.
Silver to mole.
So I'm going to show all of my work here. I have 25.5 grams
of silver.
My goal is to get to moles. What unit goes below moles?
Silver.
My grams of silver.
Yay.
What do I do now? Class, what would I do?
You would.
I would what? I'm going to find the mass of silver on the periodic table. So what's the mass of silver?
107.8682.
107 point, can I say 9? Okay, 107.9. Where does that go? Top or the bottom? Class, where does it go? On the bottom. Why? Because grams is there. And it says there are 107.9 grams of silver in how many moles? 1 mole. So now I have 25.5 times 1 divided by 107.9. So if I divide those two numbers, I would get, in this case, 0.236 moles of silver. Okay, if we go back to your PowerPoint slides, guys, I did this problem for you, and then I also did the first one here. What I would like you to do, I would like you to try these two problems for me, okay?
Way to go.
Last slide that we'll look at right now is that I'd also like you to try these two for me as well. I was going to do this one as an example, but I want to see if you can try this one. So actually, just do this problem for me. So if we go back, there are quite a few problems that I want you to try for me on your own.
Review.
On slide number 8, I want you to try those 3 problems for me. So slide number 8, you have 3 problems.